try and see if it works. Here we go. So because I had an odd exponent, the ends were going the opposite direction, and then I had n minus 1 curves. In this case, my next one has degree 4, which, because it's an even exponent, then both of my ends should be going in the same way. So n is 4, both ends are either facing up or down. Now, I don't have a negative in front here. It didn't reflect, so both ends are going to be facing up. Now, as far as what happens in the middle of those ends, I can do the n minus 1 curves. My n is 4, so 4 minus 1 is 3. I've got like 3 curves. I'm going to curve once, twice, 3 times. Okay, so there's my end behavior is going up on both sides, and I had 3 curves. Yeah. Oh, okay. So if I shift it to the left by 1, instead of hitting 0, 0, I would hit the point -1, 0, right? So I know I've got to hit that point too. In fact, because if you put this in your graph, it'll probably look so flat. The curves are so tight, it would look like, you know, so tight there. It would almost look like a parabola. But yes, both ends are going up. It curved 3 times, and we did hit the point -1, 0. So then for the next one, let's see here. All right, so Justin, what is the degree on part C here?
6.
6? Okay, so does 6 mean that the both ends will go in the same direction or the opposite direction? Same direction, good. So the 6 here is an even, so yeah, they're both going to go in the same direction. So are they both going up then, or both going down? I know they're going in the same direction, but which direction? Yeah.
Both going up because it's not reflected.
It's not reflected. There is no negative here, so both going up. I do know, at the very least, I know that both ends are going to go up. And then let's see what kind of happens in the middle here. My n minus 1, so in this case, 6 minus 1 would be 5. I'd have 5 little curves. These would be really little because all I got to do is shift. I'm going to do this -2. I'm going to shift to the right by 2. I know I've got to hit this point 2, 0. So let's see, it's going to go like 1, 2, 3, 4, 5 curves. Sure. This is supposed to be, it says sketch, right? It doesn't say it has to be perfect. I'm just putting just those generic things that I know about it. I know the ends should both be going up. I know that it should have about 5 curves, should have 5 curves, and it should hit the point 2, 0. Okay, any questions on this stuff? Yeah.
So you always subtract 1 of the numerator?
For the turns, yes. All right, so you guys take a sec, do D. So Ryan Z, whenever you're ready, let me know what you got. Yeah. Yeah, so Ryan Z, Ryan Zollinger, you got it. So Ryan, I'm looking for how many curves there are, what the ends are doing, and a specific point to hit. So yeah, Ryan, I'm looking for end behavior, curves, and a specific point. All right. So 0, -7. All right, so 1, 2, 3, 4, 5, 6, 7, 0, -7. All right. N equals 4, which what does that's true, n does equal 4. What does that tell me about the curves and the end behavior? All right, so 3 curves. And I saw Dylan say they're both, oh no, Ethan was saying that both sides are going up. So both are up with 3 curves. In fact, I think it goes like pretty tight down here. 1, 2, 3 curves. There we go. So if you guys kind of estimated this on your own, it probably didn't look exactly like this. In fact, mine don't look exactly correct. I'm putting those kind of main pieces of information that we found out about this on here. It should have the same generic shape, but it's not hitting the exact points. All right, so then let's look at, well, do you guys have any questions on this before we move on? Yeah. The vertex in A, so it would hit at 0, 0. They weren't adding or subtracting anything. So that's why I tried to hit the point 0, 0 right here. Okay, good question. And they're actually, because this was on A, because it was an odd exponent, I don't really have like a vertex. There's not like just a single point that it was curving at. But I did have to hit the point 0, 0. Okay.
So if we were to put all this in a graphing calculator, it would look relatively like this.
So in a graphing calculator, it would have this generic shape. The curves might be wider, or the curves might be a little tighter, but it would have the same end behavior. It would have the same number of curves, just how dramatic they are would be different. Okay. And in fact, graphing calculators you can't really use on the test anyway. So I wouldn't start relying on that. And then let's see, can the curves go anywhere on the line? So as far as the curves go, I'm not too concerned about those. I do want to make sure we have the correct amount of curves. But how dramatic they are, I mean, I could have made this go like down curve once, curve twice, curve 3. I could have it like make more dramatic curves, but this is fine. As long as you have the correct amount of curves, have the end behavior, and hopefully hitting any of the transformation points. If you shifted up, down, left, right, hitting one of those specific points. Okay, so we're gonna look at the leading coefficient test. So this has to do with the end behavior. The leading coefficient, either being even either being a positive or negative. So we're going to write the end behavior. So this one, here's an example. F of x goes to infinity. I'm going to treat my f of x basically saying what my y's are doing. My y's are going to a positive infinity. It's like my y's are going up. That's basically what this is saying. And the x's are going to positive infinity. Well, my x's, here's my x-axis going to a positive infinity, means it's basically going to the right. It's kind of saying that I'm going up as I go to the right. So here's what I'm going to write here. F of x goes either to positive infinity, like either up, or to negative infinity, down. My f of x, my y's either go up or down. So in this case, I'm going to put f of x, like my y's, are going to go, I'm talking about this left side, my f of x or my y values are going to positive infinity, like they're going up. As the x's go to, well, my x-axis goes to the left or the right. It looks like I'm going up as I go to the left. So as my x's go to negative infinity, it's talking about going to the left side. F of x goes to positive infinity as x goes to negative infinity. It's saying I go up as I go to the left. So it's describing the left end of this graph. I have two ends though. I have the left end and then I've got this right end of the graph as well. So my f of x or my y values are going toward negative infinity, like my y's are going down to negative infinity as the x goes toward positive infinity. So as my x's go to the right. So it's saying I'm going down as I go to the right. Okay, so that did describe both ends. The only part that can change on another graph is either a positive infinity or a negative infinity. Okay, so here's just my generic end behavior. I need to kind of fill in the blanks here. So f of x goes either up or down as x goes either left or right. So let's describe the left end of my graph here. If I'm talking about the left end, that's when my x's go to negative infinity. I'm gonna fill in that blank. But my f of x, like my y values. All right, so Dylan G, what are my f of x or my y values? Is it going toward either positive infinity or negative infinity? Positive infinity, like it's going up. Okay, so in that case, what do I say for my next statement? My next statement has to be about the right side. I already described the left side. What do I write for the right side of my graph? Okay, my x is going toward oh yeah, I think you got it. Positive infinity. My x is going toward positive infinity. If my x's are going to the positives, my x's are going to the right. Okay, so on the right side of my graph, what do the f of x, what do the y's do? Also positive infinity, like they're going up. My y's are going to positive infinity, like going up as my x's go to the right. Okay, do you guys have any questions on this yet? Good. Okay, let's have you guys give it a shot then. Look at your graph C that I have in green here. Look at that graph C, see if you can write the end behavior for that particular graph. So Shar, whenever you're ready, let me know what you got. Yep.
So for the last part of the graph, I got f of x goes to infinity as x goes to negative infinity.
All right, you said that was the left side of your graph. Looks good. You're basically saying you go up as you go to the left. That is true. Okay, what's the next statement?
F of x goes to infinity as x goes to infinity.
As x goes to infinity. Okay, so you're saying f of x goes to infinity, it's going up as we go to the right. Also true. Looks good. All right, any questions on the end behavior yet? Okay, what if you don't see the graph? What if you just get this equation? They want to know the end behavior just based off of this equation itself. So I have to recognize a couple different things. I have to recognize the degree. This is a degree 3 polynomial, like my highest exponent is a 3, which means it's going to split either going up on the left side, down on the right side, or vice versa, down on the left side, up on the right side. If it's got some odd degree, it's got to be split. Both ends have to be split. Now, then I've got a negative in front here, which is a reflection. So this would actually have the left side going up, right side going down. It could curve multiple times in there. All right, Sherry, you got a question? Okay, gotcha. And what were you saying?
Wouldn't you have to factor it out because you have a 4x there as well?
If I was looking for like x-intercepts or something, yeah, I would factor it. Because I'm looking for the end behavior, I actually prefer it not having factors. I prefer seeing the standard form, like highest exponent all the way down to the lowest exponent.
Mm-hmm.
So this setup is good for finding the end behavior. So based off of this just generic, what I'm picturing in my head is this, and the left side, so as x goes to negative infinity, that's the left side of my graph, and the left side looks like it's going up. So my y values, or my f of x, is going to a positive infinity. And then on the other end here, this is going to the right, so this is as my x go to positive infinity. Then it's going to go down, which my y values go to negative infinity as I go down. Okay, so this is kind of just a picture in my head of an odd degree with a negative coefficient. Leading coefficient is negative. All right, so then let's look at the next one here. So let's see, Ashley S. Ashley, what's your degree on part B here? What's the degree of this polynomial? Ashley, you there, honey? Ashley Salazar? So Dylan, you're right. We did not have to worry about the 4x. We were worried about the leading coefficients and the degree, which has to do with, in this case, degree 4. 4 is my highest exponent. And the leading coefficient, the coefficient of that x to the 4th, I actually don't see it. What is my leading coefficient if I can't see it?
1.
Oh, 1, they're multiplying by 1? Okay, so then that's a positive 1, which means I'm going to have an even exponent. So both sides are going up or both are going down. And I had a positive 1 multiplied in front. So both of the sides are going up. Again, it could be doing a bunch of, curving or whatever in there. But the point is both sides are going up. Okay, which means f of x goes towards, say, my y values. My y values are going to go toward positive infinity, like going up, as my x's go toward negative infinity, like as I go to the left. Oh, looks like it kicked us out. All right, let's see if we can get this going real quick. All right, there we go. Okay, f of x goes to infinity like I'm going up, as x goes to negative infinity as I go to the left. Okay, Nicole, did you catch what I was saying on this one at all? Okay, so let's look at the next part of the same problem then. I want the other end. I already talked about as x goes to negative infinity, so I already talked about the left end. let's look at the right end. On the right side here, my f of x or my y's are going up, all the way up to positive infinity. And then that's positive infinity as I go to the right. So as my x's go to positive infinity. So that's the right end. And so Nicole, to answer your question, I actually did not have to deal with the negative 5x squared because that was not my highest degree. I had a degree 4 polynomial, like my highest exponent was 4. So I was worried about this leading coefficients, like coefficient in front of my x to the 4th. Yeah, no problem. All right, let's see if you guys got this one. Try C. Yeah, pretty much, Ethan. Pretty much telling me which direction they're going. So that's why it's called end behavior. Just talking about like those arrows, which way they're pointing. So Abdi, whenever you're ready, let me know what you got.
For C, right?
Yeah, for C.
For the first aspect, I got infinity.
Positive infinity. Okay. And okay, so you're saying it's split. One side's going up, the other side's going down.
Yeah.
What do you do for your x's? Where are your x's going?
Where the X is going?
Yeah, so see on these ones, I had to say what the x, if the x's were going to negative infinity or positive infinity. Like if my x's are going to the left or the right.
They're going to negative and positive infinity.
Okay, so if I kind of translate what this says that my y's are going up as my x's go to the left. So that's like this end.
Yeah.
And then this is translated like my y's are going down as my x's go to the right. So
Yeah.
it's kind of like that.
Yeah.
Okay, and then it could curve a couple times in the middle, whatever. This is super close. It is split because you have an odd degree. That is true. However, I think it should be split in the opposite direction. Notice there's a positive coefficient.
Yeah.
It's like a positive one. So I do want it split, but I want like the right side going up and the left side going down. You get what I'm saying?
Yeah.
Okay, so these, instead of a positive infinity and then a negative,
Negative and positive.
you got it. So my y's are going down as my x's go to the left. That's this side. Nice. And then my y's are going up as my x's go to the right. So that's this arrow. Okay, so I'm just going to draw over here. I'm going to draw a little layout for you here. This might be helpful. If you have an even versus an odd, this is talking about, oops, the degree. Even or odd degree. If it's even, they're either both facing up or both facing down. Those are kind of your only options for an even degree. If it's an odd degree, they're split. Now, you know that they are both facing, even is both facing up if you have a positive coefficient. Both are facing down if you have a negative coefficient. So this has to do with the leading coefficient. So hopefully this chart's kind of helpful for you guys. The one that we were looking at in green had a positive 1 for the leading coefficient. So I was in this positive section, and it had x to the 5th. So it had an odd degree, which is why I knew that they were split. Left side went down, the right side went up. All right. So then let's see about, did you guys get this? Got written down? Okay. So we actually talked about this already. A polynomial of degree n has n minus 1 turning points. So that's what we talked about up here, like my degree was 5, so I had 4 curves, 4 turning points. That's kind of what we were talking about. So let's see. I do want to put that it has at most, we didn't talk about this yet, it has at most the n minus 1 turning points. It could turn less than that. It has to have the correct end behavior, but it has at most the n minus 1 turning points. All right, so I'm going to look at, again, my n. Out of all of these numbers, where's the n? Audrey, which one's the n? The 3, the exponent right there? Yeah. That is my n. Nice, that is the highest exponent, so that's my n. And they said you have at most n minus 1 turning points. So I've got to do a 3 minus 1, so a total of 2 turning points. It has up to 2. So Marcus, this is kind of what you were talking about as far as this was in standard form, like it's all going highest exponent down to lowest exponent. If they give it to you in this factored form over here, how am I going to find what the degree is? Like what my n is?
From the leading variable.
X squared?
I think. Guessing.
I would have to use the x squared, but it's not just x squared. And here's how I know that. If I distribute, like what's x squared times x squared? X to the 4. Okay, so this actually, if I was getting rid of the parentheses, if I was distributing and trying to have it in this standard form, if I was trying to do that, I would get an x to the 4th. I mean, you can keep going. It would be a 3x to the 4th minus a 2x squared. Great. But I'm talking about the degree. That would be x to the 4th, right? And that hasn't even dealt with this last one, the x plus 4. I haven't even dealt with that yet. So if I distributed all this stuff, keep in mind, over here, did I care about the x squared or the 4x or the 2? Like, did I care about any of that? No. So I just brought that up because as far as distributing goes, I don't need to distribute everything to find the degree, to find the n. I mainly need to do my highest exponent ones. I need to do a 3x to the 4th times a plain x, which gets me 3x to the 5th. And then I would have plus blah, blah, blah. I'd have a bunch of stuff there. But that would be my highest exponent. My n, in this case, is 5. And then I could have up to n minus 1. So I could have up to 4 turning points. So B did require a bit more work here. I did have to distribute. Honestly, I didn't distribute everything. I was just kind of looking for that highest exponent, the degree, after I distribute. All right, you guys at home, you doing okay? Oh, thanks, Dylan. Thanks, Fiona. Thanks, Nicole. All right. Doing all right? If you guys have questions, just let me know. Okay, so I'm going to then move on down here to the zeros of a polynomial function, which zeros, by the way, let's just kind of point this out. Zeros are pretty much talking about x-intercepts. Very similar. You can call it a 0 because you have to set your y values, or your f of x here has to be a 0. Which every x-intercept is some x value comma 0. That's why they're calling it zeros. Your y values or your f of x would have to be a 0. So we're going to find the zeros of this polynomial. And let's see. In this case, the factored form is actually nicer for us. So we're going to have to factor this. Yeah, you're going to solve it. You're going to solve probably by factoring. I'm going to factor out my GCF, my greatest common factor, which was, looks like a 2x squared, yeah. And then I'm still left with a negative x squared plus 1. All right, and this is all equal to 0. So I'm going to set each of my factors equal to 0. I'm going to do the 2x squared equals 0, and I'm going to do the negative x squared plus 1 equals 0. All right, so I'm actually just going to get a 0 on this. 0 squared, still 0. 0 times 2, still 0. My x value off that first equation is just 0. This next equation, though, I need to subtract 1. So I get negative x squared equals a negative 1. All right, let's change the sign on both sides. I get a positive x squared equals a positive 1. But I don't want to know what x squared equals. I want to know what plain x equals. How do I get rid of that exponent? Ooh, a square root. Which if I do a square root on both sides, great, I got rid of the exponent. But it's not just a square root of 1. It's not just plain 1. There's something else I'm missing there. Plus or minus, whenever I take a square root, I need a plus or minus, a positive 1 and a negative 1, which means I actually have 3 different answers for my x here. My x was a 0 and a positive 1 and a negative 1. So I had 3 different answers here. So it said find all of the zeros. I found all 3 of them. So yes, in this case, there are 3 x-intercepts. That is true. The 3 zeros are the 3 x-intercepts. All right, so let's look at next one. Same deal. It has to be a 0 for my f of x. This one I could factor, but I actually don't need to though. I can solve this without factoring because there's just a single x. See how there's just this guy? I don't have an x squared and then a plain x. So I can go ahead and add the 36 onto the other side. I'm going to take a square root on both sides, just like we did before. So that means I have one answer of x equals 6, yeah? No. Plus or minus, which means I have a positive and a negative 6. I have 2 different answers. Okay. But again, I knew that I didn't have to factor this because it was a plain x squared. There was no other x. The next one, though, this has an x squared and it has a 6x. So for that reason, I do have to factor this one. All right, so let's see, Ethan S. Yeah, Ethan Sorensen. Wait, so Ethan, you were asking about 3 x-intercepts on which one? A or B or C? Which one are we talking about? On the first one, yes, there were 3 different x-intercepts on the first one. That's true. Okay, so Ethan, will you look at C then? Go ahead and factor this and find your x-intercepts for C. You there, Ethan? go ahead and factor it and get our zeros. Okay, so you got a x minus 3 squared in that it was negative 3 times negative 3 is a positive 9, and then negative 3 plus negative 3 is the negative 6. Nice. Okay, so then if you're solving for x, what does your x equal in that case? So you got x equals 3, just straight up 3, or do I have a positive 3 and a negative 3? Okay, we did have to do a square root. In fact, I had to do the square root at the beginning here. So like I would get a plus or minus 0. Is there really a positive 0 or a negative 0? Yeah, it's just straight up 0. So in that case, I just had 0, plain 0 equals x minus 3. I add 3 to both sides, and I just basically got a positive 3. I don't have a negative 3 in this case. It's because I took the square root of 0. I don't have two separate signs for that. Oh, no, yeah, so it didn't carry through. It was just on the 0. Okay, any other questions? All right, I got one more I'm going to add on to this right here. Factor by grouping. Yeah.
So you just take out the DCF from the original equation?
If I could take out the greatest common factor, I would. No, on part C here, though, there wasn't really a GCF. There was nothing they really had in common. I was looking at what multiplies to be 9 and what adds up to a negative 6. And it looked like that's why we got the negative x minus 3 squared, because negative 3 times negative 3 is the positive 9. And then negative 3 plus another negative 3 is a negative 6. Is that a little better? Okay, cool. All right, so let's look at this one. I'm going to add this on here because you're going to have one on your homework. You got to do some factor by grouping. You like my beautiful handwriting? It's amazing. All right, so here's what I do when I'm grouping. I'm going to group the first two together, and I'm going to find a GCF, a greatest common factor, just out of those first two, which I think I could factor an x squared out of those guys, which leaves me with an x plus 1. All right, and then I'm going to group the last two together here. So I'm going to group my negative 9x minus 9 and my GCF, my greatest common factor out of those, is going to be the negative 9. And if I did this right, I should have the same set of parentheses here. So if I factor out the negative 9, I have an x left, and negative 9 divided by negative 9 is a positive 1. So x plus 1. Okay, those match. That was kind of a way that I could check and make sure I was on track. Now my overall GCF, greatest common factor, what they have in common is an x plus 1. So I'm going to factor out the x plus 1, like I got rid of those, and I have left an x squared minus 9. And I'm telling you what, I'm not done yet. I could actually factor even more. But do I really need to factor if I'm looking for zeros? Like if I set this all equal to 0 instead of equal to f of x, if I set it equal to 0, I could factor again. But because this one has a plain x, there's no other x's in it. The other factor has a plain has an x squared, but there's no other x's in it. So I could just set each of those equal to 0. So I'll do my x plus 1 equal to 0. I'll do my x squared minus 9 equal to 0. All right, so if I solve for x, I get x equals a negative 1. In this case, I have to add the 9 over and then take a square root, which makes me do a plus or minus. So I get a positive or negative 3. So I've got 4 different answers here. Or sorry, 3 different answers. I've got the negative 1, 3, and negative 3. Now, because I had degree 3, look at this, my highest exponent is 3, right? If for some reason I came up with more than 3 answers if I came up with like 4 or 5 different x values, I know something's off. That should be at most whatever the degree is. I should have at most, in this case, 3 x values. Okay, any questions? Then let's look at this. If it's x minus r to the m, if that is a factor of the polynomial, then r has a 0 of multiplicity m. And if the 0 is odd, again, zeros are basically x-intercepts. Or sorry, if r is a 0 of odd multiplicity. Now, m here, my exponent, it kind of tells me how many times I'm multiplying by the same thing. So for them to call it multiplicity kind of makes sense. Like, if I had the whole thing squared, it means I have 2 of the same thing multiplied together. If I had it all cubed, I've got 3 of the same thing multiplied together. So when they're talking about this multiplicity, that exponent, I mean, it kind of makes sense for multiplicity. So if it's an odd multiplicity, it crosses the x-axis at that r, at whatever I was subtracting. If I've got an even multiplicity, then it just touches or bounces off of the x-axis at that r value, which I'll show you what I'm talking about. I've got, if I set this equal to 0, I got 0.00. Well, it was x squared. That's even. So at x equals 0, I should either bounce, I'm bouncing either above or below the x-axis, but I'm bouncing off the x-axis. I'm not going to cross all the way through it. And then let's do the other factor here, the x minus 2. Set that equal to 0. So if I add 2 on both sides, I got a positive 2. 1, 2, okay, hit it positive 2. But this was like to a degree 1. This is x minus 2 to the first, to degree 1. So that has an odd degree. It's going to cross through the x-axis there. Let's think about our end behavior. So use the end behavior. The end behavior, this should have a degree 3. If I distribute this through, I got like an x cubed minus 2x squared. I have a degree 3 with a positive coefficient. It's an odd degree, so they should be split ends, and then a positive, so I should be like going up on the right and down on the left. So that's my end behavior. But again, this 2 here, that's an even number. So it should just touch or bounce off of the x-axis. I'm going to go up to that 0 and whoop, bounce. All right, this one, this x minus 2 had like a degree of 1. There was only one of them. And 1 is an odd number, so that should cross through the x-axis. So I got to turn around here and cross through the x-axis there. All right. Let's see if we can do this one more time. You guys find the x-intercepts. All right, and find the end behavior off of this one. Find your x-intercepts and the end behavior. So 80, once you get this, let me know.
Both of them, I got that x equals 0.
Okay, x equals 0.
Kind of doesn't make a whole lot of sense to me because one of them is supposed to be bouncing off the 0 and the other one needs to be crossing through it.
So what are them that you're talking about?
For example, 6, sketching the graph
Uh-huh.
and then solving for the zeros.
Okay, so what were your zeros? Just straight up 0?
Yeah.
How'd you get that 0?
I said 0 equals to 3x to the 4th, as well as 0 equals to negative 4.
Oh, that's why. So I set 0 equal to each of these because they were factors that were multiplied together. But on this problem, these are not factors. This is a 3x to the 4th minus 4x cubed. They're not multiplied together. So I actually would have to factor this first. So I'm just going to take out my GCF, my greatest common factor of x cubed. Now I have 2 factors. I'm going to set my individual factors equal to 0. Not the stuff that was added or subtracted, not my terms, but my factors get set equal to 0. So I actually had a little mess here. I got 0. I did get the 0 you were talking about, but I also got the 4/3. So 4/3, a little over 1. All right. End behavior. Let's talk about the end behavior real quick. So Laura, what's the left end doing on this one?
I'm trying to figure out the first part of the problem.
Okay.
The end behavior.
Yeah, so it's off of my degree and my leading coefficient. It's a degree 4 with the leading coefficient of 3. So degree 4 is even, right? Coefficient of 3, like a positive 3. So it's like that top left box. Well, I'm talking about the ends though. Oh, positive infinity? Yes, both ends go up to positive infinity in that box. So for that reason, I'm going to say both ends are going to go up to positive infinity. And then I got to see if I'm going to like bounce off of the zeros, if I'm going to go through the x-axis for those zeros. That has to do with the degree. Let's see, this one was, do you guys see any even degrees? Let's see. What about odds? Do you guys see any odd degrees? Oh, the 4/3, that came from this factor that was, I didn't see an exponent because it was raised to the first. That was degree 1. So that's an odd, it should cross there. Actually, this x to the 3rd, that's also an odd number. It should cross from the 0 as well. So it's going to go through 0, crosses through there. And it's supposed to turn around, cross that also. So it actually crossed through both of them. All right. So this example number 5, this was in factored form. Example number 6 was in standard form, but the standard form one, I had to factor it first. Factored form made it a little easier to see what the zeros were. Okay.
Why is there only one curve?
Okay, good question. There could be 3 curves. I could, like, look at this. I could make it go down. I can make it curve, and then I could make it curve 1, 2, 3. I could make it curve like that. But the x-intercepts, I should only hit those 2 x-intercepts. 0, 0, and then 4/3 0. So it could curve more, that's true. It would have, in fact, it would have at most 3 curves. All right, so the last thing here, you guys give me just a sec. I have one more thing to look at. Intermediate value theorem. So it's saying, this honestly makes total sense. I think if you go from a negative to a positive, like if I was going to connect my negative to positive, wouldn't I have to cross 0 at some point to get to that positive number? So what they have you do is plug in this first number, plug in -1. And honestly, I don't even care what it ends up being. I just care if it's a positive or a negative. Okay. which this ends up being, I think, let's see, 1 minus 8 minus 1 plus 2. So it ends up being a negative, whatever. I don't even care what it is. I just care that it's negative. And then f of 0, if I put a 0 in for all of these, 0, 0, 0, okay, plus 2, this gives me a 2. It went from a negative to a positive, so it had to have a 0. It had to have an x-intercept between the -1 and the 0. It went from a negative to a positive. It had to have had an x-intercept somewhere between there. So it says show that it has a 0. It didn't say you had to find the 0. It said show that it does have a 0 between there. All right. So that is the end for today. Your homework is online on the WebAssign 2.2 on WebAssign.